Our friendly duck is out on the pond on a rainy day. As it happens, 2 raindrops hit the water, just to his left and right. Circular waves move outward. The speed of the waves depends just on the properties of water, and for shallow water, the depth of the pond. This means you can control the speed of the waves by adjusting the depth of the water. When the waves meet, they interfere with each other. One way of thinking about interference is to think about a wave not as an object, but as a set of instructions. Each wave is a set of instructions saying go up, go down. If the duck is at a point where both waves are saying go up and go down in synchronization, then the duck will move up and down with both waves at the same time. We see the duck doing that here. This is known as constructive interference. When we pause the simulation, we can see a cross-section of the water's surface with the surface height exaggerated so we can see the 2 waves added together. If the duck is at a point closer to one wave source than the other, so that one wave is saying go up and the other wave is saying go down, then the duck will not move up or down at all. The 2 conflicting set of instructions cancel one another. This is known as destructive interference. Notice that if we change the depth of the pond, thereby adjusting the wave speed, the points of constructive and destructive interference change. How can we predict where waves will interfere with one another constructively or destructively? The key concept is a wavelength of the water waves. This is a distance between 2 crests or high points in the wave. If you are exactly the same distance away from 2 sources of waves, the waves will rise and fall in sync. If you are closer to one source than another, but the difference in your distance from one compared to the other is exactly 1 wavelength, you'd also rise and fall in sync. So the key point is to look at the distance to each source, find the difference in distance, and see if this equals some whole number of wavelengths. If it does, you get constructive interference. If the difference in distance equals a half wavelength, then one wave is exactly halfway behind the other, and you'll get destructive interference, since one is saying go up, while the other is saying go down. So, try different wave speeds and see where the waves interfere.